Okay, so today what we're going to do is try and find out how you would find the turning point of a parabola if you are given the equation in this form, which is the y equals ax squared plus bx plus c form, and we want to put it in the turning point format. Okay, so let me just show you what the turning point format would be. So the turning point format looks like y equals, and then we have a number in the front, which would be a, and then we would have bracket, square, and then here we would have your x, and then we would say minus b. We put the minus in white. Minus b. Actually, often they'll call this p and q, but they could call these any letter. We're going to call it p, and we'll call the other one q. Plus. Okay, now this equation is the turning point form. And once you've got this equation, it tells you that the turning point would be p and q. So notice that there's a minus in front of the p. And then the q is just positive. So whatever our p is, so say you had plus 2, it was your p. Your p would be minus 2. If you had minus 2 as your p, then your p would be 2. So now let's look at the way we do it. So first of all, to get our a, that would be the number in front of the x squared. Well, there's a 1 in front of the x squared, so we don't actually need to write the 1. We just know that our a is 1. But notice that it's not part of the turning point. It's just a number that's in front of the bracket. So if you had a number in front of the x squared, you would need to first take that out. But we don't have to do that here. And so what we do is we take that x squared and we just make it x. Then the second step is we take the number in front of the x and we divide by 2. So we divide this 4 by 2. So 4 divided by 2 is 2. So we divide this one by 2. Just use it in black. So this one here, we divide by 2. Okay. So then it's plus, and then our 4 divided by 2 is 2. I don't know if you can see that green. That's a 2 there. And then we have to just put our square over here, because that's our format there. And then then what we do then, the next step is, if you were to times this out, you would end up getting this 2 squared. So whatever we do, the next step is we minus whatever we've had here, the 2, and we minus that squared. So we actually end up minusing 2 squared here. And then what we do is we just pop that minus 3 on the, so this minus 3, that's over here. We just write it over there, minus 3. Okay, so let's go through those steps. The first step is we make our bracket squared like this. And we put our x here. Then the second step is we divide the number in front of the x by 2. Then the third step is we minus that 2 squared. And then the fourth step is we just minus the 3. Okay, and now all we do is, it's almost done, is we have the x plus 2 squared, and then we say, well, what's minus 2 squared? Well, minus 2 squared, 2 squared is 2 times 2, which is 4. So we minus 4, minus 3. And then we end up with y equals x plus 2 squared minus 7. Okay, and now we've got our turning point, which is our 2. But remember, the 2 we changed to minus, right? Because it says it's a minus there. So whatever this number 2 is, we make it minus 2. And then the q is easy. That's just this minus 7. And there's our turning point. Okay. Now what we're going to do is the next question, you find the length AB. Well, for the length of a line between 2 points, we use this following formula. Y equals, and you have a big square root sign. And then it's the first x value, x1, minus the second x value, x2, squared, plus, and then it's the y value. So this is going to have to be a bigger square root sign. It's going to go all the way through there. And it'll be then y1 minus y2. Okay. So let's now use a highlight to say, okay, what are these x values? So I can say, well, x1 could be this first x here. So that would be the pink one. And then the second one, this x2, well, that would be the other x value, green. And then the y value, we could say the first y value can then go next to the pink one. It's the first y value. And then the second y value is the other y value, which let's do that in red. Okay, and so using this distance formula, so you've got to know this distance formula. It's on your formula sheet, is on our plug and play. So I can just say now, sorry, this is not y. This is not y, by the way. This is distance. So this is distance, not y equals. Distance equals. So I'm going to just use a d there for distance. Distance of, and I can say AB, whatever the line is. So the distance, let's go back to black. Distance AB equals the big square root sign here. There, squared. Oh, these are squared. That's squared, and that's squared. Plus the other 2 squared. Okay, so what's my pink one? My pink one is minus 4. My green one is 7, but it's minus 7. So I'd say minus 7, that's in green. And then my blue is that 6. And then the red is minus 2. Now, when I minus 2, I end up saying plus 2, right? Because minus a minus is a plus 2. Okay. And now I just carry on and just put this in, right? So minus 5 minus 7 is 11, minus 11 squared. Now, the reason we square it is we always want a distance to be positive. You can never have a negative distance, right? If I go from here to here, it's 4. If I go from my right hand to my left hand, it's still 4. Doesn't matter, but so I can never have a negative. So that's why we have this square thing here. And then I plus, well, 6 plus 2 is 8. And so that'll be then 8 squared. Okay, and so minus 11 squared is 121. And then 8 squared is 64. And this comes to 185. Square root of 185. Okay. Now this value here, 185, is not a perfect square. So what you got to do, put that in your calculator. And then you get an answer. Okay, so let me get my calculator. Okay, so when I put that in my calculator, I get 13.5. 13.56. 13.56. Well, of course, we like to do 3 significant figures. So that would be 1, 2, and the 5 significant. But of course, I've got a 6 here. So the 5 rounds up to 6. So I end up with 13.6 units. Okay, so that's my answer.